In this video, we're going to use the state pattern using blueprints and add different behaviors to an object depending on what state it's in. We're going to do a really simple version so that you can learn the pattern. Then we'll talk about how you could expand it, make it more efficient and optimized using other methods. By the end of this video, we're going to have a fire trap that we implement using the state pattern. So we have an idle state, a warming state, and a hot state. And you're going to see that multiple things happen in each different state, sound effects, particles, and applying damage. You can trigger it multiple times, right? Our system is moving through the different states that each have different behavior. And the reason that this video is longer is because the purpose is to learn about how we can use states. There is definitely an easier way to build a fire trap. So just to be clear about that up front, this is just one possible way that you can use a state pattern in your mechanics using blueprint logic. So we're going to talk about enter, exit, ticking a state, how to change states, and how to add as many states as you want. So by the end, you'll understand the state pattern a lot better, and you can use this anywhere you need in your own mechanics. So before we dive into implementation, let's talk about what the state pattern is. I'm going to point you to a really helpful resource that goes over a lot of game programming patterns. It's a book called Game Programming Patterns. There is an online resource for it, at least as of now. The state pattern shows an issue where when we try to add a lot of behavior to a single object, in this case, a character, you might have jumping and ducking and shooting and attacking. And if you try to put that all in one big block and you have all these different kinds of behaviors with a Boolean tracking, it gets really confusing to try to add or modify anything to it. So the state pattern states that instead of adding all of our behavior in one big block, we can break up the object into different states where they can only be in one state at a time. So we can only be standing or only be ducking or jumping or whatever. And while they're in standing state, we can add any behavior or any visuals or whatever we want. And then when we enter, we can do things. And when we exit, we can clean up after ourselves. So this is our pattern. We really want to understand how we can take an object, define different states for that object, and then add whatever behavior we want. Because then if we want to add additional things later on, we're not potentially messing up all of our other states. We're just adding behavior to a single state. This is how we're going to approach it. And then we'll also talk about state machines and how we can do transitions and things later on. Okay, so I wanted to give two little caveats to our approach with the state pattern and blueprints and how we're going to implement it. First one is there is a new feature in Unreal that recently came out a little less than a year ago as of the time where I'm recording this out of experimental called State Tree. And the State Tree is a very visual and optimized tool inside of Unreal that will allow you to do the state pattern and you can visually see it with nodes. It's really cool. I will probably make a video in the future on it because there's just not a lot of documentation out there for it. But if you want to know more, you can read through this. This is Unreal's recommended way, like their approach to doing the state pattern for logic trees and really anything you want. I do recommend looking into this tool and seeing if it will accomplish what you want, but I still think it's important to understand the pattern if you want to use this tool. Like it's going to make implementing the pattern really easy, but only if you already understand the pattern. So we're not going to use this tool in this video. I just want to show you straight blueprints because we can transition the logic into other game engines. We're going to look at the pattern so that we can apply it in different ways no matter what engine we're looking at. But this is an Unreal specific way of doing the state pattern. So I do recommend that you look into it if you're interested in this kind of thing. The second caveat is that we are going to be using a very simple version of the pattern. We're not going to do a class-based state machine. We're going to do simple enums and just look at how that would work. In other words, we're going to use a switch statement. It's not super clean and flexible. But we're not really concerned with that. We just want to see the simplest version of the pattern for now. And later on, if you want to make it more flexible, you can. In the past, I've done videos in Unity on how to do a class-based state machine. There are probably ways to do it in Unreal, but that would be overkill for an initial introduction in the pattern. So we're not going to do a class-based state pattern. We're just going to do a simple enum-based one and look at how that would work. And so the last thing is that the whole reason that I was trying to create this video is I could not find very many resources for blueprints using the state pattern. You know, I'm used to working with this pattern for different kinds of mechanics. So when I did this before in Unity, I had a video about how to create a little fire trap where it's not doing anything and then it warms up and then it gets hot and then it applies damage and it goes in a little loop. We're going to create a slightly more complicated version of this where it will not trigger into the warming state until the player passes over it, and then it'll go into warming, and then it'll go into damage, and then it'll wait for the player to step across it. That's what we're going to do for this trap. All right, so this is our plan. We are going to create a fire trap using the state pattern. First, we're going to start off in idle. So I'm gonna draw a little blob here for my state. And then we're waiting around. The player will trigger our condition to move into the next state, but at some point we're gonna have a condition and a moving into a new state. And this new state we'll call warming. So our warming state. And then from our warming state, we're going to move into our hot state. So this is where the player would get burned. We'd apply damage. We'd do other things, play sounds, play particles and whatnot. So let's draw a little arrow here. And this is our hot state. And then after we've been hot for a little bit, we will return to idle and wait for the player to touch the trap again. So we'll have different things that will trigger the transitions between these states, but we're really only going to have 3 states. Now you could imagine the same process for any other time you want to implement the state pattern. You just have to be able to break down what that object is doing in different states. And as long as each state has different behavior, then it might be a good use of the pattern. But this is going to be our example that we're going to implement for a fire trap. All right, first thing we're going to do is create our fire trap actor. So I'm going to expand right here. I have an underscore game folder. So I have an actors folder with other things that don't matter. So I'm gonna make a new folder. We'll call this fire trap. I'll go into here and now I'm going to make my actor. This is going to represent my fire trap actor in the world. So right click, go to blueprint class, and this is a type of actor. This is something in the world, cannot be controlled. I'll just BP underscore fire trap. Save it, Control S. Open it up. Now what I want to do here is define what my fire trap is. And at this point, you can kind of deviate a little bit with the static mesh and whatnot. I'm going to use placeholder stuff and things that come with the editor for prototyping, and then you can always replace this later. So I'm going to keep my default scene root, but I'm going to add a cube mesh right here. Later on, this could actually be your own custom static mesh if you want to make a fancy fire trap thing. I'm going to keep it as a cube, but you could always replace that later. Let's resize it, say 0.1. That's really all I need for that. Just a little base for my trap, compile, save. You could also mess with materials if you want, but again, I'm gonna leave it for the tutorial. Then I'm going to also add a box collision right here. Now this is gonna represent the area that will activate the trap. So we'll call this activate volume. Compile, and we want to position this. So when something touches it, in our case, it'll be the player or a character or something, we want to trigger the trap. So I'm just going to resize this to be right above the static mesh. And I'm going to do this with a box extents. You could scale it if you want, but this feels a little bit cleaner to me. So I'm going to rough this out. I think 50, 50, 10, and I'm going to move this up just a little bit. That's pretty good. So this is going to determine if something touches this right over the top, that it is putting pressure on the trap and triggering it. Now, eventually, this trap is going to shoot up fire and is going to apply damage. So I also need another box collision here, and we'll call this damage volume. Now this one we want to stretch above the trap in an area right over here. So let's make these extents, let's say 40, 40, and then a lot taller since the fire is going to be shooting out. And then we'll just move this up. Okay, that looks pretty good. You could adjust this based on your particles or what you want for your gameplay, but this will be fine for what I need. Now, I'm gonna make 2 other things here just in preparation. Eventually, I'm going to want to have multiple different kinds of particles shooting out of the same fire Niagara system. Like I might want some smoke at first, and then I want to shoot out fire, or I want little embers and then fire. So we're gonna make one Niagara system, and we're going to swap out the asset for it and then play it depending on which state it's in. So in our warming state, we're going to shoot out one kind of particle, and then in our hot state, we're going to shoot out our big fire particles. But I'm going to play that from a Niagara system component. So I'm going to add Niagara particle system component right there. We can just call this trap particles. And I'm going to turn this off. So this auto activate, I'm going to turn this off by default because we want to choose when to play it. We don't want it to play at the beginning when we're idle. And similarly, I also want to play sound effects that are tied to this mechanic. So I'm going to add audio. We can call this trap audio, be consistent. We're not going to give it a default here, and we are going to turn off the auto activate as well. We want to tell it when to play. Compile, save. And this is our setup for our actor. I think the only other thing we need to do is put it in the world so we can test it. Let's take this, just drag it in the world. Make sure that our sizing is appropriate. If I hit play, you can run over here. That feels about right to me. So little tiny fire trap, we can step on it and then things will happen. Okay, so in order to get our state machine working, we need a couple things. The main thing that we need is a way to change our states. And I'm showing you a graph of if you wanted to abstract this, but we're not going to do this. The main thing is we need an enter for each of our states. We need a tick and an exit. So each of our states, our idle, our warming, and our hot, each need an enter, a tick, and an exit, at least for now. And then we also need a way to track the current state that we're in, since our object can only be in one state at a time. So it can only be idle or only be warming or hot. We're going to make this with an enum instead of a class, but we're going to track our current state. And then when we change to a new state, we're going to run our current state's exit. We're going to change to the new state, so warming, for example. And then we're going to run the enter on our warming. And then we're just going to keep running tick. At some point, we'll change again to hot state. So then when we change, we'll run the exit on our warming. We'll change the new state. We'll run our enter on our hot. And then we'll run the hot tick and so forth. So this is going to be our pattern. We need to set this up in order for our pattern to work. So now we're going to create a new structure where we can define all of the different possible states that we can be in. Now in the simplified state machine, you can use an enum. If this got very complicated, we might need to talk about a class-based state machine. For now, we can use an enum and it'll be fine. So let's create our structure, right click, go to blueprint and go to enumeration right here. And I'm gonna call this e_fire trap state. So these are all the possible states that our fire trap can be in. Let's Control S to save and open it up. And let's create a couple. Let's click add enumerator. The first one will be idle. In most state machines, you're going to have some kind of idle state. It's pretty common. Let's add another one. We said warming. And our last one is hot. If you wanted to add additional states later, you would also need to add another one here. But what this allows us to do is check our structure for any of these states as a name inside of our blueprints, which will just make it a lot cleaner. And it really does enforce that we can only be in one of these states at a time. We're going to track the current one as a variable. So we'll have a variable of type e_firetrap state, and then we will just set the variable on this firetrap state depending on what we're in. So let's do that. Let's create our current state. Open up our BP_firetrap, and we need to make a variable for this. So let's click the plus button. We're going to call this current state for our firetrap. And for the type, I'm going to click the drop down here. This is a type of e_firetrap enum that we just created. So this e_firetrap state. Make sure you select that. We don't really want the designer to set this. They should be using the function for this. We'll see that later on. So I'm not going to turn on the eyeball. And let's just compile save. You'll see that we have a default value, but we're going to set this explicitly once we start putting in our code. Now, if we want to change what the current state is, we are going to change this in blueprints and use this to test to see what we should be doing based on our state. The next thing that I'm going to add right here is our elapsed time. Now, we won't need this by the end of the video, but I think at first to understand the state, it is a little important. So we're going to add this for now. And we'll move this to float. Let's compile save. We can keep this as 0. Actually, let's give this a better name. It's elapsed time in state. In other words, we're going to reset this counter every time we switch our state so that we can track how long we've been in warming state or how long we've been in hot state. And we can use this as a transition condition later on. So we have our variable set up. Now let's create our ChangeState function that we can use to switch our states and run any enter and exit that we need. So let's create a new function over here, hit plus, and we'll call this ChangeState. You can make this an event, but I think I'm gonna make this a function just to hide it a little bit because it's gonna do a lot of different things. Okay, so when we change a state, we also want to request that if someone runs this function, they need to give us a new state to change to. So it makes sense to do this as a parameter. So inside my inputs on my ChangeState function, I'm gonna add a new parameter and we'll call this new state. All right, and we're gonna change this to a type of e_firetrap state. So they need to pass in a new firetrap state for us to change to if they want to change a state on this firetrap called new state. I think that's good. Compile, save. So now what we can do is we can use this new state and use our current state to be able to test the two to determine if we need to change. So for example, I typically like to test to see if our new state is the same as our current state, then don't do the transition because we don't really need to re-enter the same state that we're in. Now, not all state machines will work this way. This is kind of a preference. It kind of cleans it up and gives me some more options. But let's say in this example, I want to drag in, say, get current state, and test to see if my new state is equal to. So if I drag off of new state and I say equal to, and we can say equal enum at the top. If we do this other function equal, we'll have to convert it. We say equal to plug in this for our other enum. We can test our enums. But what I want to do is say if they're not equal, then continue. We could say if they're equal and then do false. Like if I could do this branch, right, and say if they're equal to false, but I don't like the way that that reads. What I'm going to do is I'm going to pull off my Boolean and invert it. I want to say if they're not equal, then continue. To do that, just you drag off of your Boolean, you type in not, and you scroll to the top, and we can get a not Boolean. So if these are not equal is the way that I would read this. So plug that in. Just a little preference, but a little bit cleaner for me. Okay, if they're not equal, then I want to continue and pull off the true. So what we're going to do at this point is we want to run the exit for our current state before we switch it, and then run the enter for the new one. Let's copy paste my current state over here. I'm going to pull off and type switch on e-firetrap state. So now what we can do is, this is a placeholder. I'm just going to pull this into a print statement so you can see it. We're just going to say enter, just so you can see what this would look like. Pull all of these in because we haven't implemented them yet, and say if our new state is not equal to our current state, then continue. We want to run the, actually this is not enter, it's exit for our current state. Then we are going to switch to our new state. So we're going to pull our current state in and set to, let's connect our execute pins here. We're going to set this to the new state that we passed in, right? So first we're going to run our exit condition on our current state. Then we are going to change to the new state that we passed in. And then we are going to run the enter on our new state. So we're going to do this again, copy paste our current state. We'll do our switch. Okay. Plug that in, and then we'll run our enter for whatever our states are. So we'll implement this later, but for now we're going to do a print statement. I know this is weirdly complex, but once we set up our change state, we don't really have to worry about this again unless we're implementing a new state, which we would put the exit and the enter in. So we'll look at some examples later. Exit for each of them now, and I think that's it. Oh, actually, we need to do one more thing here. I'm going to pull this over. We are going to reset the elapsed time to 0 so that we can start counting up from 0 whenever we change to a new state. Again, we're going to factor this out later. But for now, set our timer to 0. Oh, I did not connect this here. Okay, let's make sure we do that. So if our new state is not equal to our current state, then we want to continue. And we want to run the exit for our current state. Set our new one. So set our current state to be the new state. Reset our timer. And then run the enter, not exit, enter on our new state. So exit our current state, set the new one, enter on our new state. Now there's one more little gotcha here that I'm just going to fix ahead of time. Say in the beginning, we have to have some initial state. So idle at the beginning, when we set our variable default, it's idle. We want to change to our idle state when we begin, right? We need an initial state and we want to run all of our enter and stuff in idle. When we first begin, when we try to change to our idle state at the very beginning, it's not going to proceed, right? Because our new state is idle, but our current state is idle. So it's just not going to work. So I'm going to say false. We just want to skip the exit because our first one is not going to have an exit. If we're not equal to that, then we just don't want to run the exit. And then we want to continue here. Just to be clear, we're plugging this node into that node. Then we can continue. This will make it so that our idle default, when we try to change to our initial idle state, we're not going to run any exit, but we are going to continue. Okay, so I think we're good. Hopefully this logic makes sense. We'll see some examples and we'll see how we can expand it. And the last thing I need to do here is an event graph. We actually do need to run the tick of our current state. Now, long term, we're going to factor this out and we'll talk about when you want to do this and when you don't want to do this. Ideally, you want to avoid tick, but sometimes you will actually need to use it, like rotations or movement over time. So I'm going to keep it and show you the pattern, but I'll give you some tips on how to refactor it out later if you want to. So we need to run the tick on our current state that we're in. So we need to get our current state, drag and drop it, get current state. I'm going to pull this off and we're going to switch because we will have a different tick function for each of our states. Pull this up here. So at this point, we want to run some kind of tick state. So I'm going to leave placeholder again, print string. We'll just call this tick. Plug in all of our possibilities for now. And then we want to increment our elapsed time in our state because we want to count it up. So drag this in and say set And then I want to plug in our delta second, so our time since our last loop or last frame, and increment it over time. So we just want to count how long we've been in the state. Now, again, I know that timers, there's a better way to do this, but this is the pattern that we can use in different engines. So I just want to show you this first. So we're going to get our lapse time. We're going to add our delta seconds, squeeze this in a little bit, and the result, want to set the new value. So basically take our current elapsed time seconds, add our delta seconds to it, and then count it up. So set the new value. So kind of weird, but this is going to be our ticking for now. And we'll look at some examples on how to put that into the states. All right, now the last thing that we need to begin our state machine is we need to set the initial state. Now it's not enough to just set the enum, right? We actually need to use the ChangeState function so that everything gets called properly. So in begin play, we want to call our change state. We want to set the state that we want to switch to. So in this case, it's idle, and plug it in. Now, another thing that you may want to do here is any kind of setup or initialization. So if I want to set anything to a default, I would do it here. One thing I do want to do is ensure that our damage volume is not turned on at the time that we begin gameplay. So in begin play, I'm just going to turn off the collision on my damage volume. I can probably do this in the inspector as well, but I just want to really ensure that it's off. So my damage volume, pull that in, my component. I'm going to drag off of that and say set collision enabled. Now it sounds weird. It sounds like we're turning it on, but this node will allow us to choose a new collision type. So we're going to turn this on no collision, and then we'll turn this on later when we have our hot state. So let's make sure we plug in the execution pins here. Any other default initialization stuff or default parameters you want, you would set right here. So if you wanted to ensure that auto activate was turned off or deactivated for our particles and our audio, you could, but I just want to show you where you could do that. Now, important to realize we are keeping our activate volume on, so we're not going to mess with that. We're just going to in begin play, do any initial things we want. We're disabling the damage volume, and then we're changing state to idle. Now, because we have our check here, we will actually enter the idle state. So let's actually test this out. If we hit play, we should see some kind of thing here. Yeah, we're seeing a lot of ticks, right? We're running every frame, but if I were to disable the tick just temporarily, click right there, you're going to see it enter, right? Enter, because we're calling change state, and because idle is our starting state right here, because idle is starting, it would be the same. So we're ignoring that, and we are coming over here and saying enter. So I think we're good so far. All we need to do is rehook up our event tick, and I think we're good to go. We just need to implement our states. Okay, so that was a lot of setup. The good news is it makes setting up our individual states quite a bit easier. So let's go down here and look at an example. Let's implement our idle state. In order for our states to function within our setup that we created and inside of a state machine, we need an enter state, a tick state, and an exit state. We also need an exit condition, meaning that at some point we need to exit our idle state to continue on our machine, and we need to decide what that is. In our case, it's going to be if the appropriate thing touches our activate volume, right? Like if the player comes and walks over this overlap volume right here, then we can listen for that, and that will be our exit condition, and then we can transition to warming. So we need to set some of this stuff up. And let me show you how to create this first one. So we need our enter, tick, and exit. I'm going to create those as functions. Now you'll recognize if we had more than a couple states, this would be a lot. And this is where you would start to consider a class-based state machine. But again, we're going to keep this simple and just do the enum-based one for now. So let's go to our functions. We need enter, so we'll call this enter idle state. Let's create another one, call this tick idle state. And our last one, plus exit idle state. Now, another thing that I like to do with these functions is I don't think objects outside of this object should be able to even see these. I want to keep these private. So as a little bit of cleanup, I'm going to, for each of these, change the access specifier to private. Other things can potentially change the state, right? So change state could be public if you like. I think this is fine. But our enter, idle, and exit, we really do want to keep those private. We don't want other things to mess with it. So mark each of these private, right? Keep them protected. And another thing that I like to do with this style setup is to group them into categories. So anything related to my idle state, I want to make a category for it over here. So if you click our enter idle state, go to category, click the drop down. We don't have any right now, so let's make one. Call this idle state. You see it creates a little drop down category for us. Let's put our tick and our exit in there as well. So select tick idle state, drop down idle state, click on exit idle state, drop down idle state. Okay, so now we can group some of these or hide them since we will end up having a lot for our different states. Compile and save. And now that we have those created, we need to actually call them appropriately in our system. So if I go to ChangeState, where I have these placeholders, I'm going to put these in. So let's start on this side. First, we're going to remove our enter print string right here. Let's drag in our enter idle state. When we enter a new state, we want to test if our current state is idle because we just set it, right? We set our new one. If it's idle, then run the idle state function. So plug that in, double click, and in here, we're just going to say print, just for testing for now, enter idle state. Compile, save. All right, let's go back, change state. So we're going to enter our idle state if our current state is idle. Now we want to exit. So if we are ever exiting our idle state, let's remove that, pull our exit idle state, right? So we want to exit first, set the new one, and then enter. Just make sure you don't mix up the enter and exit right here. So our idle, if our current one before we set the new one is idle, then we want to exit our idle state. So plug that in. Let's double click and leave another print string for testing. You can always remove these later. Exit idle state, compile, save, come back. Okay, so we have these two, and the last thing we need is our tick, event, graph, event tick. So I'm gonna get rid of this, and I'm going to pull in my tick idle state right here. Pull this one in, pull that one in. Okay, so I'm not going to put a print statement in this one because it's just going to clog up our debug log. So I'm going to leave that one out. But I think we have it all hooked up. So at this point, I can compile, save, and we can test it out. So we're entering idle state, but we don't have any exit condition yet, right? We're just going to stay inside this idle state forever until we build an exit condition. So that's what we're going to do next. So to build our exit condition, we need to think about what it would require to move from idle to warming. And to me, this is a little bit easier to wrap my head around than trying to put all this logic in a big thing. This is where the state pattern is going to start to show how it is useful. So what we're going to do is we need to listen for if something entered the activate volume. So I'm going to click my activate volume over here, and I'm going to hit the, scroll down, the on component begin overlap, this plus button. So right here, what we want is we want to create an event that we can call when this activate volume is overlapped. And the cool thing is we can listen to an event whenever we want, and we can stop listening to an event whenever we want, meaning that in some states, we can listen to see if this is triggered. And in other states, we don't want to know if activate volume is triggered because once we're warming, we can't like re-trigger it or something. So we're going to do this with an event dispatcher. And the other reason that I'm doing it this way rather than connecting directly into this is I want to show you how you can build events to listen to for your exit condition. So let's create a new event dispatcher and let's call this onTrapTouched. So when something begins overlapping with this thing, let's drag this in and call our event, meaning that there was an overlap and we can send out the notification to anything that is listening. The trap was touched. If you care about this, do something. If not, no big deal. So call onTrapTouched. Now that we've created this, we can actually listen in to our event. You can do this with any of your other states too. It's just a really handy pattern. Compile, save. And what we really want to do is we want to run something in response to onTrapTouched. Generally, when you subscribe to an event, you want the response to have the same signature. So like if our onTrapTouched, we're passing information. So like, you know, where it was touched or who touched it or whatever, we need to match that information with whatever we're responding to. But in order to respond with ChangeState, this does have a parameter. And so it's not going to match our new state, our eFire trap state here does not match with the nothing. Now we could make an input to make it match, but I don't really want to do that. I just want to show you the more generic way to do it. So in response to call onTrapTouched, let's make a new function called activate trap. And this is what's going to run our change state to our warming. Now we're going to do this from the idle. Potentially other things can activate the trap, like other objects can, but we're just going to keep this as a separate function. And all we're going to do here is change state to warming, right? We're activating the trap. We're starting the sequence. So warming and then hot. So change to our warming state, which we haven't implemented yet. So we're going to do that and then come back to our event graph. All right, so let's think about what we need now. When anything touches the trap, so it can be set off by other things as well, whether you want that or not, it's kind of up to you. You can filter it right here if you like. We're sending out the notification that it was touched. And what we want to do here is on enter idle state, we want to start listening to this event so that when it's touched, if we're in idle, we can run activate trap in response. But when we exit, we want to stop listening to this event and stop responding with the activate trap. Because once we're in warming state or hot state, we don't want to listen for this event. We don't want to re-trigger it. So let's see how to implement that. Double click on enter idle state. I'm going to keep this here for now. I think it's fine for visualization. In idle state, let's bind a response event, so activate trap, to our on trap touched notification. Now it's really simple to do this. If I were to drag and say bind just means listen to, essentially. Let's drag that in. Now, normally we have the plug for an event, right? And we would have to try and find one. We try searching for activate trap. We don't see it. What we can do is we can just create an event that will connect our function into our event. I want to show you this way because you may think that you can only do this with events, like you can only use this in our event graph and then we can't really use functions. Not really the case. All we need to do in here is if we drag off of event and say create event, now we can bind this to a function. So we're going to come down here on signature, come down to activate trap. And the reason I'm doing it this way is just we can't really plug our red node into our activate trap. We need to do this conversion to make it work with the a function. So it's just really handy to know that you can bind functions to event dispatchers as well. I'll show you this once, but after this, I'll just do it this way. So we're going to bind and start listening to our on trap touched when we enter idle state. If we get the notification, we're going to run activate trap. But once we exit, so double click exit idle state, we want to stop listening. So again, we're going to drag in our on trap touched. We're going to say unbind, drag in. We're going to do the same thing here. Say create event, select function, activate trap. Okay, so we're going to unbind our activate trap response when we exit. So when we enter our idle state, start listening for on trap touched, run activate trap in response. When we exit, stop listening to on trap touched, and do not run activate trap in response. So we will only activate trap when we're in idle, essentially. It's a little confusing. I'm showing you this so that you can understand how you can use event dispatchers for your exit condition. So let's compile, save, and then once we do actually run activate trap, we're just going to change state to warming. All right, kind of a little weird. I think the other ones are a little less complicated. Let's see how this works, or if it does work. Hit play, see enter idle state. If we enter, we should exit idle state, and now we're in warming, but we haven't really implemented our warming state yet, but we are actually exiting appropriately. And you see if we re-enter, we have stopped listening, so we're not re-entering, right? So I think we're done with our idle state, and now that we have done our exit condition into warming, we can set that one up. All right, so I got to the end of this section and realized that we were going to have a bug here. Let me show you what that is. An event graph, when we're setting our initial state and our current state to idle, but we also want to change our initial state to idle, when we change our state over here, normally we wouldn't want to go into the same state that we're already in, but we want to make this exception for the initial state. So what I'm going to do here is I'm going to move all of this over. And what we were doing before is just saying, if this is the same state, so false, just skip and go over here. But the problem is later on, this would allow us to change into the same state that we're already in, and I wouldn't want that. Really what I want to do is just test, is this the initial state? If so, then ignore this exit stuff since we're not currently in anything that we want to exit. Just ignore all this stuff and set it and then go into the enter. So we just want to make an exception for the initial change state. So that's what we're going to do. The easiest way to do this is just to create a variable, call this is initial state. I'm going to change this to Boolean. Let's compile this. And for the Default value, we're going to default this to yes. And the first time we test it and it's true, we're going to set it to false because then it would no longer be the initial state. So we're going to do this with a branch, scoot everything over as much as you need. We're going to take this in here and we're going to test. So pull and say get, pull off of that and say branch. Is this the initial state? If it is, then we're going to do some stuff. If not, then we want to continue. So first I'm going to plug in the not and say just continue. Then if it is, then I'm going to set. So drag in our isInitial and say set. I'm going to set my isInitial state to false because it's no longer the initial state. We're using it right here. And then skip all this stuff and plug it into set. And we need to make sure that we plug this in. So we're doing our initial test. I think this does warrant a comment. If this is initial state flag and skip our exit. Okay, because we're not going to have an exit because it's the very first state we're entering or the first time we're changing our state. We're going to skip all this and go straight into our set. Now, the other thing we need to make sure that we're doing here is we want to not allow, so hold Alt, click false, not allow our change state if after this, if it is the same state. So if we're already in warming state and we try to enter it again, we don't want to do that. We just want to exit and not do anything right there. So I think this will fix a bug later on. Once we start trying to change our states, that will not allow us to change into the same state we're already in, but we're building a little exception here for the first time we change. So let's test this out real quick, make sure that our little fix here worked. Again, we just added this Boolean, set the default value to true, and if it is true the first time, we're setting it to false, and then continuing and skipping our exit. And then make sure that you disconnect this false that we did earlier. So only allow us to change if it is not the same state. Let's try it out. Make sure that our initial one works, enter idle state, exit idle state. Okay, cool. We're not getting the call twice, and it is not calling exit right when we begin, which is exactly what we want. All right, next, let's look at an example on how to implement our warming state. So this is going to be a pretty simple one. We're in idle. If we touch the trap, we'll enter warming state for a small amount of time, and then it'll automatically go into hot state. But in our warming state, we want to place some little smoky particles, which we could replace later, and probably a sound effect to let us know that our trap has begun warming. So let's look at what it would take to implement a new state in our system that we set up. First thing I need to do is I need to create my enter, tick, and exit. Long term, if you knew for sure that you didn't need a tick or didn't need an enter or an exit, you wouldn't have to make those. But for now, I'm just going to make them all just to show you, just to get the pattern down, I think. So let's create a couple new functions. We'll call one exit warming state, make another one enter warming state, and another one tick warming state. Okay. And for all of these, I'm going to give it a category and make it private. So let's give it a category first. Let's make a new one since we don't have warming yet. We'll call this warming state. And we're going to compile, change the access specifier to private since we don't want other things to call this state change, just this actor. And we have one set up. Let's do the same thing on enter and tick. So on enter warming state, do the category warming state, it's already there, and do the access specifier to private. Do the same thing on our tick warming state. So category warming state and access specifier private. Compile save. Now it is grouped. Now we need to actually call these at the appropriate time. So let's go to our change state and let's start over on the right. First, we're going to enter warming state. So let's call that when we enter, drag that in, connect it up, spread that out a little bit. Go over here, and for our exit, we're going to do the same thing. So exit warming state. Whenever we need to exit, we're going to call that, plug that in, move it up, and connect the output pin as well. And the last one is our tick. Go to my event graph. And remember, eventually we're going to factor out our ticks, but for now, we want to see what this would look like. So we're going to say tick warming state. You can drag that directly into the pin and then pull it out just to hook it up a little bit easier. All right, let's move this out a little bit. Ourselves some room here. All right. Okay, so we're calling all the states appropriately. Let's just leave a little print statement just so we can debug easier. So in enter, we'll say print string enter warming state. The same thing for exit. So double click, print string exit warming state. I want to make sure that these are getting called appropriately and not multiple times, and just that it's all progressing properly. So double click our tick warming state. And this one, we don't really want to add a print statement. It's just going to clog up everything. So compile, save. And this is our basic structure. So everything is calling appropriately, but we don't have any logic yet. Okay, the next thing that we need for our new state to function properly is we need an exit condition. Otherwise, it's going to always be in the state and it does not have a way to leave. So we're going to do this in our tick. We're going to factor this out later, but for now, we're going to check every single tick. Has our elapsed time exceeded our warming duration? So our elapsed time in this state that we're already tracking an event graph, we're counting this up and we're saying, has this elapsed time exceeded our warming duration? Now, we haven't really set a warming duration yet, so let's define that somewhere. Let's create a new variable, warming duration. So this is the amount of time we want to spend in our warming duration state. Change this to a float, and let's give this a default of maybe 1 second. I think is fine. Let's give this a category too. I'm going to put this in a warming state category inside my variables just to keep all this tidy, compile and save. And now inside of our tick warming state, since we're counting this up every delta seconds, we'll just test, has the elapsed time exceeded our warming duration? So to do that, we're going to drag off and say branch. Just doing a test here, basically an if block. And we want to test our elapsed time and state, which we were already handling the counting for. So get elapsed time and state and saying, is this greater than or equal to our warming duration? So drag that in. If it is, so drag in the condition check here. So if we have exceeded it, then we want to change to a new state. So true, change state to hot. So this is our exit condition. And then once we transition, it'll handle any exit stuff for our warming and everything should be fine. So we now have our exit behavior here. Let's make sure that we're actually seeing the exit called and make sure that we're transitioning appropriately. Hit play. So enter idle state, exit idle state, enter warming, and then exit warming after 1 second. Okay, so our structure is in place. Okay, now that we are transitioning out appropriately of our warming state, we want to think about the behavior we want. And this one's pretty simple. For our warming state, all we want to do is play some looping particles, play a one-shot sound when we enter, and that's it for this one. So just a really simple example. First thing you typically want to do is create any assets you need. So for my particles, let's create a very simple Niagara system, say next. And I'm going to do my fountain default since I want it to shoot up from the trap, but we'll make it very not intense and make it gray. So kind of placeholder for now. Select fountain, hit plus, hit finish. We'll call this PS_fire trap warming. Control S to save it, open it up. And while you're in here, this is pretty intense. I want it to look more like smoke. So a really easy way to do this, which you could replace with other tutorials later. Let's go down to our lifetime. Let's say lifetime minimum is 0.5, lifetime max is 1. Let's also make this kind of gather around the bottom of the trap instead of shooting up from a single point. So let's expand the sphere, scroll down to sphere radius and change this to 100. Okay, that's a little bit better, but it's shooting too high. So let's scroll down to our... Actually, let's make the gravity less. So instead of -980, change that to -500. And it's just shooting out too fast, too high up in the air. So let's go back to our velocity, just down here, maybe something between 150 and 300. Yeah, that's fine. So it's pretty close to the ground and kind of just looks like it's rumbling with smoke. And then our fire will shoot up in hot state. So 150, 300 at our velocity, compile save. It's good enough for placeholder. So now that we have the warming state particles created, we need to actually play it. Inside of warming state, when we enter, so enter warming state, we want to take our trap particles component, set it to our smoke particles, so the one that we just made, and then activate it. When we exit, we want to deactivate it. So when we enter warming state, let's drag in our trap particles component. We're going to set to the Niagara system that we just made. So drag off and say set Niagara system asset here. So set this to an asset. We're going to choose our PS fire trap warming. So take that component. We're essentially just assigning our system asset in it, but through a blueprint node. Connect that up. And another thing we might want to do here is expose this to a variable so we can assign it over here instead of digging through code. Always a good idea. I'm going to right click and promote to variable after I've assigned it to the right one. And pull this down here, and we're gonna relabel this. It's not a very good name. We'll call this warming particles. Okay, and then we're gonna compile, save. And if you assigned it before you promoted that variable, it'll go to the proper one that you assigned over here. But if not, just make sure you assign the default over here to the fire trap warming one that we created. Okay, so we've assigned the asset, but we have not told it to play yet. We actually do need to activate it. So pull off of trap particles and say activate that, activate, connect that in, compile, save, and this will activate it properly, but we want to make sure that we turn it off. Anytime we enter a state and we turn on something, we need to make sure that we turn it off when we exit. I'm going to go to my exit warming state, and all I need to do here is just deactivate our trap particles component. So drag that off, pull off, and say deactivate. All right, so whatever is on there, just deactivate it. We don't have to clear it out. You know, we're going to reassign it whenever we need, so that's fine. Pull that out over there. So we just turn off our warming particles, compile, save, and I think we can test it. Let's test it out real quick. Hit play. So we don't see any particles at first, but when we touch this, we're going to enter warming state. It should turn on the particles and turn it off whenever we exit, so after 1 second. Turns on and then off. Okay, this is all we need for our particles and our visual for our state. Okay, so now we want a one-shot trigger as well, just to indicate to the player that they did activate the trap and we are now entering the warming state. Technically, you could put this in our activate trap function, but I was really just using this to pass it through. I think it makes sense that anytime we enter our warming state, we want to play a one shot right at the beginning. That way, it's a little bit more proofed than if we just call it from activate trap. We don't know that activate trap is the only way to enter warming state. It's just one possible way to enter the warming state. You know, your mileage may vary. I'm going to put this in our enter warming state. All I'm going to do here is play a quick function, just pull off, say play sound at location. I don't really need to play it from the trap audio. You know, you could if you want, but I just want to play it at a point. It's not really looping. It's just a one-shot trigger, so this is fine. And the location, pull off of that and say get actor location, arrow down, get actor location. So we're going to play it at the location of our BP fire trap, since that's where we are putting this node. And the last thing is I want to, well, I guess I want to choose a sound here. This one, it's a sample one. You can make your own, you could import it. You really just need it to be a trap activation type of sound. I think I found one via our grab. Let's see what this sounds like. Yeah, I think that's fine for testing. We can always replace this stuff. At least that's the goal. So put that in and then right click, promote to variable. We want the designer to be able to reassign these later. We'll call this activate warming sound, compile, save, and make sure that the default is over here assigned. So pull that down and, you know, let's clean up a little bit. Let's do our warming particles that we made before. Let's assign the category to warming state. And let's do the same thing with our activate warming sound. Category warming state. So now it's all grouped together. Anything related to our warming state is all in one place, and that makes more sense to me. So compile, save. Let's test this out. Hit play. Should hear a sound and see the particles begin. And then it stops because we're in hot state, which you haven't really implemented yet. So this is our warming state. It's pretty simple. It's just kind of a pass through, wait for a small amount of time, trigger some particles, play a sound. But I hope you're already starting to see how, since we are compartmentalizing our behavior into states, we can expand this and make this more complicated. And even if we make it more complicated, it's not interfering with our other states, as it would be if we had one big mess in one giant sequence, right? Like that would make it very, very confusing of what state we're in. Instead of just breaking it out explicitly into states, now if we want to know anything about what's happening in our tick warming state, we go there. We want to know anything about our tick idle or our enter warming or exit or whatever, it's a lot easier to debug this way in particular, but I think it's a good setup. So we're done with our warming state, and now we need to move on to our hot state. All right, same thing as before, just to remind you of the setup, we need to create our enter, our tick, and our exit, and then set them to trigger appropriately. So let's do that all right here. We'll create 3 new functions. So first one is enter hot state. And another one, exit hot state. Our last one is tick hot state, right? We want to put in our categories. So click one, do category. It doesn't exist yet, so we'll call this hot state. Assign it, make it private. Do the same thing with our exit hot state. Assign it to hot state category and make it private. Same thing with our tick hot state. Assign it to hot state and make it private. Okay, double check that this is all here. We're underneath our category appropriately. Okay, now let's drag these in where they need to go. So I'm going to close out a lot of these. You can see that with this pattern, we get a lot of different functions. Again, there are ways to do a class-based one where we are pulling a lot of functions into smaller objects. For now, I really just want to show you the pattern, and you could implement this in other ways later. Okay, hot state. Let's go to our change state. When we enter, so at the very end, I want to enter our hot state. So drag that in, plug that into hot, make sure that execution pin is plugged in. When we exit, we want to make sure that we exit our hot state, plug that in, and drag off of that into our set. Make sure that you connect these endpoints as well. Compile, save. And the last one is our tick. So let's go back to our event graph. In our event tick, we are going to plug in our tick hot state right there and connect our set into our lapse time. Compile, save. Then we're going to go into our enter hot state. We're going to pull off and do a print string for debugging. Enter hot state. Same thing with our exit. Double click our exit. Print string exit hot state. Compile, save, and we're going to leave our tick hot state alone. Now for our tick hot state, it's really going to do the same thing that we did for our warming. So I'm just going to go ahead and do that here. Go to our tick hot state. We need to check our exit condition. So we're going to do another check to see if our elapsed time has exceeded our hot state duration, which we have not created here. So let's create our variable and we'll call this hot duration. Let's compile, save that, give that a default. I think 1.5, let's say 2. Let's do 2 seconds in our hot duration. Compile, save that. And then we're going to do a branch. So drag off in our tick hot state, do branch. And we're going to pull off our hot duration, say get. We also need to pull off our elapsed time and state, say get. And if our elapsed time is greater than or equal to our hot duration, again, make sure that you put this default here, otherwise it will not work. So I have 2 seconds. I'm going to pull this over here. And if this is true, then we want to go back to our idle, right? So if true, change state to idle. All right, default to idle, just make sure that you set these properly. And now we can test it out. So compile, save, make sure that our exits and our enters are working appropriately. Enter warming, enter hot, exit hot, go back to idle. Okay, this is our full loop. We don't have any behavior in our hot state yet, but we have completed our state machine. For our hot state behavior, the main thing that we want to do here is we want to enable our damage volume. So this damage volume that we created earlier, we want to enable collision on it so that during hot state, if something touches the damage volume, it will either take damage or destroy it. For me, I'm just going to destroy it since I don't want to implement a health system as part of this tutorial. It would just take too long. So let's activate our damage volume on enter and deactivate it on exit. So let's find our enter exit. Enter hot state. Once we enter one time, we want to turn on our damage volume. So drag in our damage volume. So get this one. Remember, we have 2, right? So I want to make sure that we get the correct one, our damage volume. Drag off and say set collision enabled and turn it on. So the new assignment for set collision enabled, we want to be collision enabled. Query and physics. That should be fine. You can obviously customize this stuff if you want. For more specific use cases, which really all we need to do here is just turn it on. So let's go to our exit and turn it off. Let's drag in our damage volume, get, drag off and say set collision enabled, turn it to no collision. So turn it back off. Okay, double check that you're actually doing the correct things in the dropdown in case you get a bug. That's why we're testing it as we go rather than one time at the end. If it's not working as you're seeing it's doing with me, then you need to make sure that you troubleshoot that before you continue. And just as a reminder, when our damage volume is touched, we're not really doing anything here. So let's actually do that. Damage volume, scroll down. So select that. On component begin overlap. We need to decide what happens when something touches our damage volume. Now, there are a lot of things you can do here. This would be the appropriate place to test the other actor, right? And then you would see if they implement a damage interface, or you could apply damage and then their damage component would respond appropriately. For me, just because I'm testing and I don't want to add a damage system to this tutorial because it's not the focus, I'm just going to see if this is a character. So I'm going to cast to character. Again, I know this is not the best way to handle this, but again, it's not the focus of the tutorial. So if it's a character, because I want to destroy the player or an enemy character, potentially, then I want to destroy the actor. So long term, this would be refactored into if it has a health system, then apply damage or kill. Or you could say, if this is the player pawn, then kill, but I want to destroy both. Well, really, I want to destroy anything that's a character. So this will work for me for now, but this is obviously placeholder. So compile, save. And so while our damage volume is active, if another actor touches it, then destroy it. This will just destroy any characters, which is fine for now. So let's test this out before we continue. If it's hot. Okay, destroy my character, which is functioning properly. Okay, the last thing we need for our hot state is our particles and our audio. So we'll handle the particles first. First thing, you usually want to create the particle effects. For me, it's going to be placeholder that then a VFX artist could go in and, make this better later on. For now, it's placeholder and put into the hookup. So let's create a new Niagara system, say new system from selected. That's fine. Scroll down to fountain. We're going to make our fountain. We're just going to turn it red. So select fountain, hit plus, hit finish. Call this PS underscore fire trap hot. Control S to save. Open it up, and I am literally just changing the color. So scroll down, change this to red. We don't want to spend our time here because we're just trying to get our system working. We're not focusing on particles yet. So change that to red, save it, come back out, and now we need to actually play it. So open up our blueprints, go to our fire trap, and on enter, we want to set it into our trap particles and activate it. So enter hot state. Over here, we'll take our trap particles, drag that in, drag off, and say set Niagara asset, just like we did before, system asset. Pull that up, connect it in, and choose the asset we want. It's the one that we just created, PS underscore fire trap hot. So we're setting it, but we're not playing it yet. So let's pull off of this and say activate. Pull that up, plug it in. And we also want to make this a variable. So right click our asset and say promote to variable. Pull it over here, give it a better name because it's not a good name. Instead of in asset, let's call this hot particles. Compile, save, and just verify that we're setting the correct one in the default. But the designer could always change this later. And I also want to set the category on these two things that I created as well. So our category, change hot state. So our hot particles are now in the hot state category. Same thing with the hot duration. Let's put the category on that, hot state. Okay, now it's grouped appropriately. So now that we're turning it on and enter, let's actually go and turn it off and exit. So let's get our trap particles, drag that in, pull off, deactivate, pull that up. Connect it in. So on exit, we want to deactivate. We don't really need to clear it out. Minimize and test it out. See, when we touch it, warming, hot. Then it turns off and we can retrigger it. And we get destroyed if we touch it while it's hot. Okay, so we are visualizing the state. Now we need the sound and the audio for our hot state. Now in this case, I wanted to show you how to do both a one-shot activate sound, but also a looping sound. And in my case, I actually have the starter content, so I can play a looping fire sound that I have here. So my fire 01Q, right? So I'm gonna play this looping sound. If you wanted a different looping sound, you would just have to find that or create that or whatever. But as long as you have a looping sound for your state to loop, then you should be fine. So let's open it back up. We have our trap audio component that we made earlier. This is where we want to play our looping sound. So let's pull this in. So we're going to do this similarly to our particle system where we are going to pull in our trap audio and we are going to set a new sound into it. This is called set sound. So drag off of trap audio, type set sound. And we need to set in, so connect our execution pin, to set in a new sound. Now this is where you would choose one. You'd have to make sure that it's looping. For me, my fire 01Q is what we want. So as long as you have a looping sound properly set up, you should be fine there. I'm going to right click and promote this to variable like we've been doing before. And we will just call this hot looping sound. Make sure that we set our category over here to hot state. Okay, we're going to compile, save, make sure that our default value is set appropriately, and should be good. So we're setting the sound, but we're not playing it yet. So we want to drag off our trap audio and activate it. Now remember, we turned off our deactivate at the very beginning so that it would not begin playing. So our auto activate over here on the component, we just want to double check that that's not turned on so that when we do activate it, we're activating it in code. Set sound, activate it, make sure you connect all this in. This is our looping sound. We want to make sure that we turn this off when we exit. Go to exit, undo anything that we do when we enter. So our trap audio, drag that in, pull off and say deactivate. Okay, so we're going to deactivate our looping audio. All right, compile, save. And we also want our one-shot trigger as well. We kind of want some little explosion or whatever that fire shoots out at first, and then we hear the looping as it continues to shoot out. But we really want to make it clear to the player that hot has just begun. It's dangerous. We want to indicate that with a one-shot in addition to a looping. So we're going to play a one-shot as well. In enter, we're going to right-click, play sound at location, plug that in. Want to choose a sound. I think an explosion is fine. I think that comes with the starter assets, or you can find your own. Do an explosion cue, probably over the top, which we could replace later, but it's good enough. Let's right click, promote this to variable, pull this down here, and we'll call this hot activate sound. Or you could call this one shot, whatever makes more sense to you. Put this into the hot state category. Compile, save, and because we assigned it earlier, it should be the proper one. Just make sure you set it down here in default value if it is not. So we're going to play this sound at a location. We don't want 000. We want to pull off and type get actor location. So the location of this fire trap, and this is where you would want to decide for yourself, like if you had a lot of fire traps near each other, you may want to make the attenuation for the sound really small. I'm not concerned about the sound design with this yet. I really just want it to play appropriately. Then the sound designer can worry about all that other stuff. So compile, save. We are turning on our looping sound and enter and playing our one shot. And then in exit, we are deactivating our particles and deactivating our sound. Compile, save. And honestly, I think this is it. Let's test it out. Make sure that our sound is working. All right. I think that's pretty good. Let's try it again. So a little bit of a delay on that sound, but honestly, the sound designer can fix that later. So this is our full loop. We have our behavior, we have our audio, we have our particles. There's still a little bit of cleanup we can do, but this is our system. You can start to see the power in this, right? Like we're defining each of our enter and exit. We are very clear what state we're in. We can continue to make this more complicated. We can add more behavior. And we're reasonably sure that if we work this way, we're not messing up our other states. We're only deciding what happens when we enter hot, or only deciding what happens when we exit idle or whatever. It's just an easier way to think about complex behavior. If we can put it into different states, we have more control and we can transition into multiple different ways because our states are self-contained. So we could have a scenario where idle goes into hot state instead of warming. We would just make an exit condition for that and it would still work because we are doing our enter and our exit appropriately. So this is the basic system. After this, we're going to do a little bit of cleanup and optimization, but I hope you start to see how you can build complex behavior using this pattern. So I mentioned earlier, even though our state pattern usually recommends that we do some kind of ticking, inside Blueprint specifically, event tick is a little bit heavier on our resources than if we were to do this directly in code, either in C++ or whatever engine you're using. So in this case, I have other tools that I can use to refactor some of this out. So I want to show you how you could do this. In an ideal scenario, you would only use enter and exit to determine your conditions. You wouldn't check something inside of tick. You can't always do this. Sometimes you need tick to rotate your object while that's in a behavior or to move to a location over time. But in my case here, I can because I'm just testing an elapsed time. I'm going to use timers to factor that out. And in my idle, I'm testing if an event happened, which we can, just wait for that event trigger. So we don't really need to use our tick. So what I'm going to do here is I'm going to delete this part right here after. And technically I'm still running my tick here just with zero logic. I'm leaving it here to show you that if you wanted a tick for one particular state, you could still leave this in and run that. But for the other ones where you don't need tick, you don't have to run it. So we're still running our tick, but we're not really doing any behavior. So I think it's fine. If you were able to factor out all of your tick state functions, you could just delete this and turn off tick and you would be fine. But I'm going to leave this here just in case you need it later, just to show you where you would plug that in. So I've deleted this. We need to now fix our transition conditions where we are counting up the elapsed time. So the other thing I need to do over here is in ChangeState. Let's double click our ChangeState right here. We are still counting up our elapsed time, but I'm going to transition this into timers instead. So I'm going to delete that as well, plug it in, move it over. So instead of tracking an elapsed time float that we are counting in our variable, I just want to set a timer. So let's compile, save. We actually need to go into our elapsed time. So our tick for warming, let's delete our transition. Actually, let's delete all of this, right? We don't need any of this. Okay, so we're clearing out our tick state entirely. Let's do the same thing with, let's go to our tick hot state. We don't want any of this. Delete, delete. Let's close some of these out, make sure that we're not getting in over our heads. And our idle, I think we made sure that that was empty already. So our idle, so all our ticks are empty, so it should be fine. Oh, one last thing. Our elapsed time and state, since we're not using it anywhere and we compiled, if we delete it, it should just allow us to delete it. So we know for sure we are not using it anywhere. So what we're going to do here, instead of counting up elapsed time, we are going to enter. So when we enter our, let's start with warming state. So up here, we enter our warming state. We're just going to set a timer and run a function in response. So once we pass a certain amount of time, so that'll be our hot duration, we're going to run a function that will then change the state. So this is called set timer by function name. Because we're inside of a function, it's just the easiest way to do it. Instead of plugging into an event and doing some weird conversion, we're just going to set timer by function name. So we are enter warming state. After we do all these other things, we're going to set timer by function name. Right here, we're not going to loop. We're just going to run a function name after some duration. So let's plug in our warming duration, right? So enter warming, set a timer, wait this amount of time, and then call this function in response. So whatever our warming duration is, we want to call a function. Let's create our callback function for this. So our function up here for warming, let's create a new one, hit plus button. I'm going to call this on warming timer ended, just to be very clear that this is a callback function. When I look at it, I know that this is getting called in response to something. There's probably better ways to do that, but I really just want to show you how you can do this. So when our warming timer ends, we want to change state to hot. And then once we create this, we want to make sure that when we enter, we want this exact same name. So since I already created this, I'm going to select it, hit F2, Control C, and paste it in just like that. So we know that it's the same name. Let's compile and save. And let's actually categorize this as well. Let's put this on warming state and let's change this to private. Compile, save. Okay, so when we enter our warming state, we're going to set a timer. We're going to have that timer wait our warming duration and then call a function in response, which are grouped over here, which will just change it to the hot state. Let's also do this for our hot state as well, since we're already in here thinking about it. Let's close these out. Okay, when we enter our hot state, when we do all these other things, we are going to pull off set timer by function name. We'll create this in a second. We're going to wait our hot duration, pull that down, and we want to run a function in response once this duration has happened. So let's scroll up, create our function, call this on hot timer ended. Let's set the category to hot state, change the access specifier to private. And in response, once our hot timer ends, we want to change state to idle, back to idle, compile, save. Let's come back into our enter hot state and make sure that we're actually calling the function that we just created. So on hot timer ended, select it, hit F2, Control C to copy, click over here into our function name, Control V to paste. Okay, so run this specific one. You really have to double check the spelling here, otherwise it won't run. It'll just fail silently, and we don't really want that. I think this will work. One quick note here, just because I think some of you might be thinking about this. If we really just want to run our change state in response instead of passing it through, like why can't we just run that? And the reason is because our change state has an input over here. And when we run our set timer by function, to my knowledge, we can't really like run something with a parameter. So instead, We're just creating a pass-through function. So we're running this. Since this doesn't have a parameter, we're just calling this, and then we can run whatever we want after. So that's just the reason that we're doing it. Okay, let's compile save. That was a lot, and let's test it out. Make sure that everything still works. Okay. And it goes back, and we can trigger it multiple times. Great. Okay, so everything is working as it should. And the good thing here is that we don't really need our event tick. So since none of these need a tick function anymore, we can just not even tick in our state machines. I'm going to undo, in case you decide you want to add tick later, like you could leave that there. It's not really causing that much harm. But if you wanted to optimize, you could totally turn off ticks if you can fully refactor it out. In some cases, you do need the tick in a state machine. So you can't always do it, but I wanted to show you some situations where you could. If you can listen to an event, right? We did that in our idle over here. We started listening to an event, and then when we exit, we stop listening. This is one very useful tool for not running ticks. And the other is using timers, which you looked at. So timers and events are really your best tools there. In a perfect world, you would probably be doing a lot of logic-heavy things inside of C++ anyways. But honestly, I think learning how to do this in blueprints just to learn the pattern is a good, useful first step. Okay, let's recap a few of the things that we talked about here. We built a simple state machine with 3 different states for our fire trap. But I think it's worth thinking about what it would take if you wanted to add an additional state, because the whole reason we would want to do this is to make our states modular. We could add as many states as we want. We just need to see what the steps would look like. Now, because we are doing a simple state machine, meaning we are using enums and putting all our logic in one place instead of a class-based state machine where our states would be their own little classes, whenever we add a new state, we have to add it in several places, which obviously is not as ideal, but that is a downside of a simple state machine. More complex one, it's a lot more set up front, but easier to expand later. But I think this is fine for a lot of use cases. And really the focus of this video is the simple state machine. So let's recap what it would take if we wanted to add a 4th state. I'm not going to actually add the 4th state. I just want to walk through what it would take. So remember that at the very beginning, we had our structure, right? Let's actually save our fire trap. We had our eFireTrap state. First thing we would need to do is to add our state inside of our structure. So we need to create a 4th state here. So if I were to add a 4th state, we could call this deactivated or something. Maybe there's a way to turn off or destroy our trap. Maybe we have a deactivated state. Control S. All right, come back. We open up our fire trap, you're going to see that it adds another to our possible states because it is one of our possible states now. If we did want to add the implementation for our fire trap state, we would need to then create our enter, our tick, and our exit. We need to create those. We would need to go into our change state. We would need to hook them up appropriately, right? Just like we did with these, right? Then we would need to have our exit condition. So in our case, just as an example, we had our enter hot state. You would need to add the exit condition for that particular state. Like what does it take to exit deactivated? Maybe there is no exit condition for deactivated. Maybe there's a way to fix it or reactivate it and go back into idle. I don't know. That's the beauty of this, is you could decide any of that you want, but you typically need an exit condition when you add a new state. And then the last thing is just add the behavior. So what happens when you enter your new state? What happens when you exit? What happens on tick if you need that? And then just make sure that you undo anything that you do inside of enter. So if you activate things in enter, you deactivate them in exit. So I know it's a lot. There's a lot of steps to do that. Again, that's the downside of a simple state machine. But I honestly think it's better to learn using a simple state machine before you try to do the complex one, just to learn the concepts. So just one last recap on that. We added a new state in the enum. We created our enter, exit, and tick. We would plug those in appropriately in our change state. So actually call them, or if you don't have an enter or an exit, or you don't need it, just don't put it there. Just call the enter, tick, and exit where you need them. Then create your exit condition and then add your behavior. So a lot of things, but this is the process for adding a new state if you wanted to continue to add to the system. So hopefully this helped you understand the state pattern. It's a really cool one, but it is kind of complex at first. But you can see that if you understand this pattern, you can add as much complexity as you want. And Unreal has a lot of systems for AI and things. I like state machines for simple AI, so like little traps and things, or if you want a system to govern itself, like maybe you're doing a turn-based system or whatever, like you really want to lock it down. This is when state machines are very useful. So I hope you learned something new, how you decide to use this in your own projects, or if you decide to make something different or more complex, cool, go for it. But I really wanted to teach you how you can use a state pattern inside of Blueprints.